In this video, we're going to use our coordinate calculation sheet to calculate the coordinates of our four stations. We're going to use information that we have calculated in our previous sheets. Namely, we have the four whole circle bearings for each of the four lines in our traverse, along with, from our traverse plot, we have the four distances for each of the four parts of the traverse. Our first part is to fill in information that we have previously calculated. So, looking at the line column, first of all, we're going to fill in the first line in the traverse, starting from point A, where we had measured the whole circle bearing. The first line in the traverse is line AB. The whole circle bearing that we know that we had measured for this one was 100 degrees, 30 minutes, 0 seconds. And the distance A to B from our traverse plot is 47.596. All distances here being in meters. The next part in the traverse, we have line BD. The whole circle bearing is 189, 30, 18.12. And from our traverse plot, the distance that we had calculated, 21.082, that can be filled in under the distance column. The next line in the traverse is line DC. The whole circle bearing being 279 degrees, 15 minutes, 11.24 seconds. And from the traverse plot, the distance that we have is 47.673. And the last part in our traverse is lines C to A. Here, the whole circle bearing, 9 degrees, 42 minutes, 14.36 seconds. And from the traverse plot, the distance that we had calculated, 22.106. Before we do any calculations, we're going to add up our four distances and place the total under the sigma D column, our cell at the very bottom, and that will give us a total distance of 138 meters, 457.457. That will give us a total of 138 meters, 0.457. The other bit we can fill in is the first coordinates of the first station we're dealing with. We're starting at station A, or control point A, and we're going to give it coordinates of 1000.000, working to 3 decimal places, 1000.000 for the eastern and for the northern. We want to choose a coordinate for the eastern and the northern, so that whenever we work out the coordinates of control point B, D and C, that they are all positive values. So with values of 1,000, anything that we calculated based on our starting point, we shouldn't have any negative values. The first stage in our calculation sheet is to calculate the partial coordinates. That's your delta E and delta N. To do the partial coordinates, so what I mean by partial coordinates is that for each part in the traverse between stations, we're going to split it up into a horizontal distance and a vertical distance. Delta E being the horizontal component, delta N being the vertical component. Here you can see the two formula that we're going to use. So calculated partial, delta E, is the distance that we have for the leg times the sine of the whole circle bearing. So for the first one, we will do 47.596 multiplied by the sine of the whole circle bearing for this line, which will be 100 degrees, 30 minutes, 0 seconds. Plug that into the calculator and you get your partial coordinate. In this case, it will be 46.7990. Repeat for all the cells in this column using the next whole circle bearing and the corresponding distance, then the next whole circle bearing and its distance, and the last whole circle bearing and its distance. Completing those calculations, you would get minus 3.4814 minus 47.0527 and 3.7261. The partial eastern is the horizontal component. Notice that some of them will be positive and negative, so it's important not to ignore the minus sign. The next part is to calculate the vertical component, the partial northing. For that, we're going to use the formula distance involved, but now it's going to be times the cos of the whole circle bearing. So for the first cell, we would use the same corresponding distance, in this case 47.596, and that will be multiplied by the cos of the whole circle bearing, which in this case will be 100 degrees, 30 minutes and 0 seconds. That will give us a value of minus 8.6737. Repeat for all the other cells in this column, again using the whole circle bearing with the corresponding distance. Careful, we're using the cos ratio rather than the previous sine ratio. So we have 3 sets of calculations to perform. The answers for these: minus 20.7926, 7.6656, 21.7897. For these, work into 4 decimal places. Before we start to do any correction, what we're going to do is we're going to add up our partials. So for the partial ecents, we have 4 values. We're going to add them together and put the total in the sigma delta E cell minus 0.0089, and likewise for the total of the delta n's, we have 4 values. We're going to add these 4 values up and put the total in the sigma delta n cell. First, we're going to calculate the closing error and the fractional accuracy of our survey to see how good our survey has worked out to be. For the closing error, we're going to essentially apply a little bit of Pythagoras to our sigma delta E and sigma delta n. So our closing error is minus 0.089, square that, add it to minus 0.0109 squared, and take the square root of that, and we find our closing error is 0.0141 meters. To calculate the fractional accuracy, which gives a measure of how good the survey was completed, we take our sigma d, our total distance that we've covered in the 4 parts of the traverse. In that case, it's 138.457, and divide it by our closing error, 0.0141. That gives us a value of 9,849.5. To explain the fractional accuracy, we want to compare our calculated value of 9,849 against given standards. So for a precise survey, we would be looking for the fractional accuracy in excess of a value of 10,000. For a semi-precise survey, the fractional accuracy would be in the region from 5,000 to 10,000. And for a low accuracy survey, our fractional accuracy would be less than 5,000. In our situation, the fractional accuracy falls in the semi-precise survey region. Now looking back at our coordinate calculation sheet, what we want to do is to calculate the adjustments necessary. When we've had previously added up our partial eastern and partial northern columns, here at the bottom we got values of minus 0.0089 and minus 0.0109. This represents a slight error in our measurements and calculations. What we're going to do now is to apply the Bohich method of correction, such that whenever we add up the partial coordinates, the partial e's, the partial n's, that they mathematically should add up to give us 0. So therefore there is no closing error. The method we apply for this is the Bohich method of correction. The formula for this can be seen here. And the idea or principle behind this is that the total deviation that we're out gets split among the 4 parts of the traverse, but longer parts of the traverse get more correction than shorter parts. To explain the calculation we do for the adjustment, what we do is we take the distance for the leg of the traverse, in this case 47.596, divide that by the total distance travelled. Here you can see at the bottom it is 138.457, and we multiply that by our total delta E, which is minus 0.0089. That gives us an adjustment for this part of the traverse of minus 0.0031. Repeating the same calculation, except for the next row, we're going to use a distance of 21.082. We'll still use the same total. So we'll use the same total distance, 138, and multiply that by our total delta E, which is minus 0.00889, to give us an adjustment for this one of minus 0.0014. Repeat the same calculation, updating with a new distance for each part of the traverse. The next cell, we would get an adjustment of 0.0031, and for the last row, with using the distance of 22.106, you would get an adjustment of minus 0.0014. That's the adjustments column completed for the easterns. Now we're going to do the adjustments for the northerns. Again, we're going to use the same ratio, the ratio of the length of the traverse to the overall distance travelled. So for the first row, it was 47.596 divided by the total distance travelled, 138.457. Now this time we're going to multiply it by the total delta N, which is minus 0.0109. For this cell, that would give us an adjustment of minus 0.0037. For the next row, repeat again, updating the distance for this part of the traverse. The distance in this case, 21.082. Divide that by the total distance and multiply that by the total of delta N minus 0.0109. The adjustment in this case is minus 0.0017. Repeat for the next two cells using the corresponding distance. We would get an adjustment of minus 0.0038 minus 0.0017. These adjustment values are the values that are going to be applied to the partial coordinates such that they will slightly change the partial coordinates, such that when we add them up or add up the column of values, they should be mathematically correct, i.e. the totals for the adjusted should give you a value of 0. So now to do the adjusted partial easting, we're going to take our partial easting and take away our little adjustment in this row. What that means is we're going to take 46.7990 and take off the adjustment. It is also a negative number, so you effectively add on the amount to give us an adjusted value of 46.802. Repeat for the next row. Our partial easting and the adjustment for the easting are highlighted. Here we have minus 3.4814. Take off minus 0.0014, and that would give us an adjustment value of minus 3.480. Repeat for the next two cells using the partial and the corresponding adjustment. Here we would get minus 47.050, and finally we would get 3.728. Now, because these values have been adjusted such that whenever we add up our four adjusted eastings, it gives us a value of 0. These values are mathematically correct. Now we repeat the same process, except we're going to use the calculated northing and the adjustment we need for the northing in each row. Similarly, we would take for the first cell, or for the first row, our calculated northing minus 8.6737 and take off our adjustment minus 0.0039, careful about the double minus, and that would give us an adjusted coordinate of minus 8.670. Repeat similarly for the next row, our partial northing and the adjustment for that part of the traverse. That would give us a value of minus 20.791. For the next two rows, partial northing, the adjustment for the northing in that row to give us 7.669. And for the last row, partial northing, the adjustment for that northing to give us a value of 21.791. Then whenever we add up the 4 adjusted northings, these 4 values, it would give us an adjusted value of, or total delta n of 0, proving that these are mathematically correct. To finally calculate the coordinates of our control points, we're going to start with control point A, and we've given it coordinates of an easting of 1000 and a northing of also 1000. Looking back at our plot, you can see that the coordinates of point A is where we started from, and because we go around the traverse in a clockwise direction, the next point that we're going to calculate the coordinates of will be at point B. So coordinates of control point B will be based upon the coordinates of the previous point. We're going to add on the adjusted partial easting in this column. In this case, it's a value of 46.802 to give us a coordinate of 1046.802. That's the easting coordinate. For the northing, again, we would use the previous northing, which is also 1000. And we'd add on the adjusted northing, which is a value of minus 8.670 to give us a northing value of 991.330. If we look back at our plot, then after point B comes point D, and then we will calculate the coordinates of point D. Control point D is our next point, and we're going to use the previous coordinates and add on the adjusted partial easting. So in this case, it'll be 1046.802, and we will add on a minus 3.480, and that would give us an easting value of 1043.322. Similarly, for the northing, the previous northing is 991.330, and we will add on the adjusted partial northing in this row. That will be a value of minus 20.791 to give us a coordinate value of 970.539. Now, if we look back at our plot, we've got the coordinates for point D. After point D, we are going to plot or calculate the coordinates for part C. Similarly, we're going to use the previous coordinate. Here we're going to have control point C using the previous coordinate of D. We're going to add on the partial. In this case, it's the minus 47.050 to give us a coordinate value of 996.272. And similarly, for the northing, the previous northing, 970.539, add on the adjusted partial northing, which is 7.669, to give us a coordinate value of 978.209. Now we have all the coordinate values for the 4 control points, A, B, C and D. But for one final check, if we look back at our plot, after control point C, we come back to control point A. So hence, if we take the coordinate values of C, add on the adjusted partial easting, the adjusted partial northing, we should come back and get the same coordinate values as we have at the top of the table. So here, 996.271, add on the adjusted partial easting, 3.728, and it brings us back to the initial coordinate for A, which is 1000.000. And similarly for the northing, 978.209, add on the adjusted partial northing, which is 21.791, gives us back a value of 1000.000, and that matches our initial coordinate. At the very end, we have 1000.000 for both easting and northing. That matches the initial coordinates at the very start. We can then state that the control point A coords start equals control point A coordinates at the end, giving us confidence in all of our calculations. Here you can now see that your coordinate calculation sheet has now been completed.